Hello my dear students, today I will explain you chapter number 12, linear programming, or we can say LPP, that is linear programming problem. So what is linear programming problem? Before that you should know two type of the basic concept. That is, first is from the class 10th, that is the pair of linear equation in two variables. That is how many methods we just take to the solution of pair of linear equation in two variables. And the second one is the concept of linear inequality from class 11th. The linear inequality in one variable and linear inequality in two variables. So these two basic concepts firstly you should know before starting the linear programming chapter number 12. So let's see. The first one, pair of linear equation method, that is which method we use to solve the pair of linear equation. So here you already studied about the elimination, substitution and cross multiplication method. Okay, and the second one is concept of linear inequality. Concept of linear inequality. This concept also we should know, linear inequality, and linear inequality in one variable and two variable both. We already studied, that is how we find the solution of linear inequality in two variable by the graphical method. Okay, so we already learned the graphical method in class 11th in the linear inequality of two variable. Let we take an example to just understand the concept, that is how we will apply this concept in the linear programming. Let we have a line 2x, we have an inequality 2x plus y greater than 50. Okay, so firstly, to define this inequality on graph, or we just have to find the graphical solution of this inequality, firstly we will change it into the equation, that is 2x plus y is equal to 50. The same procedure we have to do in the linear programming also. And now we just find out 2 points to draw this line. Let x is equal to 0, then y will be 50, and y will be equal to 0, then x will be 25. So one of the point we find 0, 50, and second one point we find 25, 0. So we can draw this line in the coordinate system. So let this is the xy plane we take here. So one of the point is 0, 50. Let this is the line we draw. Okay, this is the given line, and this is the point 0, 50, and this one is the point 25, 0. So what we already studied in the linear inequality, that is if we have to draw any linear inequality on the graph, so firstly we will change it into the form of equation. After changing into the form of equation, now this is linear equation. So we draw the linear equation or a straight line on the graph. Now by the concept of this linear inequality, we just check which one is the solution, this region or this region. We should know that every line we draw in the coordinate system or coordinate plane, it divides the plane into two parts. This is the first region or this is second region. One of the region is towards origin and the second region is away from origin. Okay, so here we have to given the greater than inequality. So how we will check that is the region is towards origin or away from origin? For that, what we do, we just put the point 0, 0 in the given inequality. So when we put the point 0, 0 in the given inequality, so we found that 0 greater than 50, because 2 into 0 plus 0, that is equal to 0. So 0 greater than 50, and we know that 0 never greater than 50. So the point 0, 0 does not satisfy this linear inequality. That's why the region is not towards origin, the region will be away from the origin. So the region of solution of this inequality will be away from the origin. Okay, and also one is most important point. Here we have to given only inequality, or we can say pure inequality, not greater than equal to. So this line we will draw dotted line. Okay, because the solution not lie on the line, we draw this line dotted because the solution of this linear inequality not lie on the line. Okay, this is just away from the origin. So this is called solution of this linear inequality. Okay, so this type of concept we already studied in class 11th. Now we apply this concept in linear programming. So before that, firstly we should know the structure of linear programming, that is what is the meaning of linear programming and where we use the linear programming. In many real life of problems, there are some of the problems which seek to either to find the maximum profit or to find the minimize of the costing. Example, that if there is any transportation problem, okay, we are doing some transportation. So in the transportation, our target to minimize the cost of transportation. Okay, in business we just want maximum profit. Okay, these type of real life value problems we discuss in the linear programming. So in the linear programming, when we discuss such type of problems, so there are many factors which affect the problems, the given linear programming problem. Let's see the structure of linear programming problem, that is how we can define the linear programming problem, which factors will affect the linear programming problem, how we define our objective, Okay, so let's see the mathematical formulation of LPP. So what is the mathematical formulation of LPP? So in the mathematical formulation of LPP, the first very important point, that is what is our objective. Okay, so this is basically called objective function. So the first one we have to given in the problem is objective function. Objective function which has to maximize oblique which has to minimize. Okay, so this is basically called objective function. Objective function always denoted by z, and z always we write down in the form of linear combination of two variable, that is ax plus by. This is the format of objective function, z is equal to ax plus by, and in the exam we have to given the question. In the question, the first objective function we have to given which should be in the maximize or we have to minimize. So this is the objective function. In the mathematical formulation of LPP, the second point is very important, subject to constraint. The second important point is subject to constraint. Subject to constraint, that is which factor or which condition will affect this objective function for maximize or minimize. These are called subject to constraint. Subject to constraint always given in the form of linear inequality, as like a11x, a12y less than or we can say greater than equal to b1, or a21x, a22y greater than or less than equal to b2, a31x, a32y greater than or less than equal to b3. So maximum we have to given the three constant according to CBSE 2022-23 syllabus. Okay, so maximum we have to given the three constant which either in the form of greater than equal to inequality or in the form of less than equal to inequality. So these are called subject to constraint. Okay, the third one is called non-negative condition. Non-negative condition. So what are the non-negative condition? That is the values of variable always greater than equal to 0. That these are called variables, or we can say decision variables. So the values of decision variables always be greater than equal to 0. This is called non-negative condition. So this is the proper mathematical formulation of LPP. Okay, so this type of LPP we have to given in the question of linear programming problem. Okay, so this is the mathematical formulation we understand of the LPP. After this mathematical formulation, there are some of the definition, that is solution of LPP. What is the meaning of solution of LPP? The meaning of solution of LPP, the values of x and y, or we can say the values of decision variables which satisfy the constraint and satisfy the non-negative condition. This is called the solution of LPP. Second one is, what is the meaning of feasible solution? What is the meaning of feasible solution? So the meaning of feasible solution, this is also the solution of LPP, but the meaning of feasible solution is the solution which satisfy the objective function, or we can say which optimize the objective function. What is the feasible solution? The solution which optimize the objective function. Meaning of optimization, either maximize or minimize. So this solution is called basically feasible solution. Third one is feasible region. The third point is feasible region. Okay, so what is the meaning of feasible region? When we draw the inequalities, example that we have to given the two inequalities, we draw it and we find their common region. Okay, so this common region either bounded, or we can say somewhere this common region is unbounded. Okay, so by the given constraint or the given inequalities, when we draw on the graph, as earlier we already studied in the class 11th, which I explained you in the starting of the lecture. So we can see that there are two type of the region. This is the bounded, okay, and this is unbounded. This one is bounded and this one is unbounded. This one is unbounded. Okay, so there are two types of the region, bounded and unbounded, and this region is called feasible region because all the solution point lie in that region. That's why this is called feasible region. Okay, so this is the very important some of the concept which we should know about the LPP. Okay, and the next thing now. The next is important point and some of the theorems we discuss before starting the problems of LPP. Okay, let's see. The next point is convex set. Convex set. So what is the meaning of convex set? The meaning of convex set, example that we have to given some of the region. Let this is the region R we have to given. We draw a line in that region. Let we draw a line segment in that region AB. If all the points on that line, lie in that region, then this is called convex set. But sometime we have just like the set. Example that we have to given the set like that. Sometimes we have to given this set, and if we draw the line, let line segment AB we draw here, but every point lie on that line, not lie in that region R dash. Okay, not all the point on the line lie in the region R dash. If not all the point lie on the line not in the region R dash, then this is called not a convex set. This is not a convex set. But if all the points on the line lie in the region, then this is called convex set. So why we are going to study the convex set? Because when we find the solution of the LPP, this solution is always called a convex set. Or we can say the feasible solution of LPP, always lie in the convex set. So that's why we are going to study a convex set. So here the important point, that is solution of LPP is a convex set. Solution of LPP is a convex set, and based on this one we have a theorem. Now before starting the theorem, we should know one of the important point. When we find by the graphical method, when we find the feasible region, either it is unbounded or bounded. Okay, then we find that there are many points in that region. There are infinite points of the solution in that region. Then how we can recognize at which point at which point the given LPP is going to optimize, either maximize or minimize. So this is very tough process. So to make it easy, we just study the theorem. Now according to that theorem, if we have to given the region R, now this region R is the feasible region, and we have to given the objective function z is equal to ax plus by, which is either maximize or minimize, then solution of this LPP always lie at corner point. Then solution of LPP always lie at the corner point according to that theorem. So the meaning of this theorem is, so whenever we have to find the solution of any LPP, we always draw the corner point and we find the solution only at the corner point. We always find the solution only at the corner point. This is the meaning of the theorem. Okay. The solution at the corner point, that is, problem will be maximize or minimize always at the corner point of the feasible region, right? So this is the meaning of the theorem. Now the next thing, we already studied in the feasible region there are two type of feasible region, bounded or unbounded. So in the LPP, in the linear programming problem, we are just going to study two type of problem. One is which one is bounded, and the second one which is unbounded. When we have to given a bounded LPP, so in the bounded LPP, the maximum or minimum of the given LPP always lie at the corner point. And exist. The solution always exists in the bounded LPP. But when we have to given the unbounded LPP, then maximum oblique minimum Z, if exist, there is a condition. In the unbounded problem, maximum or minimum Z may be exist or not be exist. If maximum or minimum Z exists, then it will be exist always at corner point. This will be exist at always corner point. So there are two type of the problem in the LPP we discuss. One of the unbounded and second one is bounded, and second one is unbounded. Two type of problem we discuss. Now one of the problem we take here. Okay, we discuss one of the problem and just understand the concept of LPP, that is how we have to solve the given LPP in the paper. Okay, we have to given the LPP into two format. One is the mathematical format and the second one is the word problem. Okay, the word problem we have to change in the mathematical format also. But here I just want to discuss a mathematical format of LPP only to understand the concept of bounded, unbounded and the solution, that is how we will find the solution of LPP. Let's see, we have to given a problem, solve the given LPP, minimize Z is equal to 4x plus y, and subject to constraint, we have to given x plus y less than equal to 50, 3x plus y less than equal to 90, and x greater than equal to 0, y greater than equal to 0. This is the LPP we have to given. So any LPP which we have to given in the paper, always given in that format. The first objective function we have to given, the second subject to constraint we have to given, the third one is non-negative condition we have to given. So let's see how we solve this LPP. So to solving this LPP, firstly you have to change all the inequalities into equation form. That is, first in equation form x plus y is equal to 50. Let this is equation 1. We draw a table because we have to draw this on the graph. Okay, 0, 50, 0, 50. Okay, and the second inequality we change into the equation. Let we change into the equation 3x plus y is equal to 90, and when we draw its table, then it will be, when we will put x is equal to 0, then y will be equal to 90, and when we will put y is equal to 0, x will be equal to 30. So here we draw the table of both the equation x plus y is equal to 50 and 3x plus y is equal to 90. In the LPP, the most important point when there is a question of LPP in the paper, okay, then you have to know that you have to draw the graph of given LPP very clean and clear, okay, because the maximum marks of graph will be awarded, okay, and the rest of the marks of the theoretical part. This is the theoretical part of the solution we are going to discuss here. First we change in the equation. After changing in the equation, we just find the region of both inequality. Region of first inequality. For the region we put 0, 0. The first inequality we have to given x plus y less than 50. So when you will put 0, 0 in that, then you will find 0 less than equal to 50. Yes, satisfied because 0 less than 50. So when it is satisfied, then the reason is towards origin. Then in that case, reason is towards origin. In the similar way, second inequality 3x plus y less than equal to 90. You will put 0, 0, then 0 less than equal to 90. Satisfy, so its reason also towards origin. And whenever you have to given the non-negative condition, so non-negative condition x greater than equal to 0, y greater than equal to 0, combinedly it shows the first quadrant. Combinedly it shows the first quadrant. Okay, so this is the region we find out. In the first step we change into the equation. The second step we find their region. Also in third step we have to find the intersection point. We have to find intersection point of both line. Okay, x plus y is equal to 50 and 3x plus y is equal to 90. Okay, we can see that the coefficient of y is same and also the sign is same. So we subtract it. So y and y cancel out. It will be minus 2x and it will be minus 40. So x will be equal to 20, and we can found that the value of y is 30. So 20, 30 is the point where both line intersects. Okay. Now, after all these calculations, the next target, that is we will draw the graph of the equation. Now, this is the important step. In the LPP, we should know that when we will draw the graph of equation, the feasible region, either bounded or unbounded, always lie in the first quadrant. Okay, so when it is always lie in the first quadrant, so you have to take the vertical line or horizontal line like that. The graph always comes in the first quadrant, not in second quadrant, third quadrant or fourth quadrant. Okay, so let's see how we will draw the graph. But before drawing the graph, you can see that in the first table x is maximum 50, in the second table x is 30. So we will take 10 units is equal to 1 centimeter or 1 box. Okay, so here we can draw the point 10, 20, 30, 40, 50, 60 and up to so on, because on the x-axis we have to given maximum till the 50. On y-axis you can see that till 90. So we can draw 10, 20, 30, 40, 50, 60, 70, 80 and 90. Okay. Now to draw the graph, we just plot the point. The one of in the first line we have a point is 0, 50. One of the point is 0, 50 and the second one is 50, 0. Okay, these are the point and we draw the line. We draw the line here. Okay, so the first line we draw through the scale. This is the line 1 we draw here, and the line 1 equation we just write down here, x plus y is equal to 50. Second line also we draw 0, 90. Like this is the point 0, 90 and this is 30, 0. Okay, so we draw this line also. Let we draw this one line. Okay, so you have to draw this not by the free hand. You have to draw the lines through the scales properly. Okay, and let the equation of this line we have to given 3x plus y is equal to 90. You just write down like that, 3x plus y is equal to 90. Okay, so this is, we write down the equation of this line also. Now we, and also x greater than equal to 0 and y greater than equal to 0 always lie in the first quadrant, and the first equation region is towards origin. So we just draw that first equation region is towards origin. Towards origin we draw the two arrow. Okay, that is this region of the first equation. The second one equation is also the region towards origin. So if we combine both of them, so the region is this one. Okay, but x greater than equal to 0 and y greater than 0 always lie in the first quadrant. How it will lie first quadrant? This is y greater than equal to 0. This region is y greater than equal to 0, and this region is x greater than equal to 0. So if we combined all of them, x greater than equal to 0, y greater than equal to 0, and line 1 and line 2, then we will find that this will be the common region. This will be the common region of the LPP. Okay, so this is basically called feasible region. This is basically called feasible region. We just draw it and darken all the boundaries. We just darken all the boundaries. Okay, and draw this region. This is basically called feasible region. We also draw the point here. Let this is point A, 30, 0. This is point B, intersection point, that is 20, 30, and this is point C, that is 0, 50. And this region is called feasible region. This region is called feasible region. Also, you have to write down the scale. That is, on x-axis and y-axis, what we have taken, 10 unit is equal to 1 centimeter. Okay, this is the scale we have taken here, right? So through the scale we just draw the graph, and this graph is having the feasible region, bounded feasible region, which have the corner point O, A, B and C. So this is very important step to solve the LPP. Now after that important step, the last step only the remaining, that is we have to check where we optimize or where we can optimize the given function, because the objective function which we have to given and which we have to minimize, so we just want to see at which point it should be minimized. So for that, in the last we just draw the table, and in the table one side we just put the points, and here we just write down z is equal to 4x plus y. One of the point we have to given 0, 0. Second one point we have to given 30, 0. Third one point we have to given 20, 30. And the fourth point C, this is 0, 50. So when we will put 0, 0, then z will be equal to 0. And when we will put 30, 0, then z will be equal to 120. When we will put point B, then it will be 24 into 20, that is 80, and 30 into y, that is 110, and z is equal to 0, 50, that is it will be 50. So we can found that the maximum value of the problem will be on z is equal to 120. This is the maximum and this is the minimum. Okay, so this is the minimum value, this is the maximum value we found here. Okay, so this is the procedure, that is how we have to solve the LPP. In the next lecture, I will explain you that is how we can change the word problems into the mathematical format, and then we have to follow the same procedure, and also we do the problems based on unbounded feasible region. Okay, thanks to all of you, my dear students.